Hi my dear students, myself Sachin. I am continuing the topic of superelevation. In the previous video we have learnt what do you mean by superelevation, what are the types of superelevation, what are the construction methods of superelevation, and what are the advantages of superelevation and what are the disadvantages of the superelevation already. Now I am start up with the problems. That is nothing but in the examination one more thing you can expect a problem or either a superelevation concept. If they ask a superelevation concept, they will not ask for the problems, or in some cases they may ask for both. Okay, let us start off with the first model. The radius of the horizontal curve, that is nothing but r is equals to 100 meter. And one more thing, these superelevation problems are similar to the your surveying horizontal design of horizontal curve problems. That is you have already learnt in the surveying 3 or third semester or fourth semester, surveying 1 and surveying 2. The design of the horizontal speed is nothing but v is equals to 50 km per hour. So totally there are two types of the velocities. First one is meter per second, another one is kilometer per hour. While considering kilometer per hour, the design speed will be v plus f is equals to v square divided by 127 into r. We should know about this formula. And the coefficient of the lateral friction is f is equals to 0.15. So f is equals to 0.15 and r is equals to 100 meter and v is equals to 50 kmph, and the formula is E plus f is equals to v square divided by 127 into r, and substitute the all values in this formula and get the required data. What they have asked, calculate the superelevation required for the full lateral friction. Next, calculate the coefficient of friction needed if no superelevation is provided. So here E should be 0. Next, calculate the equilibrium superelevation if the pressure on the inner speed and the outer should be equal. If you want more information, you can refer the textbook, Kanna and Gesto or Kadiali, anything, to go through the textbook and solve the problems and submit it. And the second problem, a two-lane road width of the with the speed of 80 km per hour. Again the speed v is nothing but kilometer per hour. Formula is E plus f is equals to v square divided by 127 into r. The horizontal curve of the radius is nothing but 480 meter. And the rate of the superelevation for the mixed traffic. So here we need to find out the E itself. And next, by how much would be the outer edge of the pavement raised with respect to the center line if the pavement is rotated with respect to the center line. And one more thing, go through the notes which is I have provided in the WhatsApp group or anything, and go through that and solve the problems. And the third one, design of the superelevation of the highway curve, that is 500 meter and the speed is 1000 kmph. That is also similar problem. And the fourth one, design of the speed is highway 80 km per hour, then the highway curve is radius is 200 meter, then certain locality, calculate the superelevation needed to maintain the. And one more thing, I am just clearly mentioning you, for the all four problems the formula is nothing but E plus f is equal to v square divided by 127 into r. Here already written. Nothing but here we are taking ruling radius of a horizontal curve, nothing but ruling gradient. Just we are telling E plus f is equals to 127 divided by into r. Just we are replacing. We know the formula E plus f is equals to v square divided by 127 into r. Just I am replacing r with E plus f here. The minimum radius of the curve for the ruling design of the speed is in meter per second or kilometer per hour is given by v square divided by 127 into the bracket E plus f. So based on that problem, you need to design the problem. Calculate the value of the ruling minimum and absolute minimum radius of the horizontal curve for a national highway plane terrain. Here we see the terrain is plane. Assume the ruling design speed of the minimum speed is 100 and 80 km per hour respectively. This problem is I have taken from the textbook. Just go through the textbook. Next, widening of the pavement on a horizontal curve. Why we need to provide the widening in a horizontal curve? On horizontal curves, especially when they are not in a very large radii, it is common to widen the pavement slightly more than the normal roads, because while providing the curve areas to avoid the accidents and skidding, we need to increase the width of the pavement, that is nothing but widening of the pavement. The vehicle occupies the greater width, rear wheel don't track for the front wheel, known as an off tracking, nothing but a vehicle with four wheels in a curved areas, the rear wheel and the front wheel does not track with the same, that is known as an off tracking. For a greater visibility at curve, the driver have a tendency to not to follow the central path of the lane but use to outer side of the beginning of the curve. Next, off tracking. An automobile has a rigid wheelbase and only front wheels can be turned. When this vehicle turns to the negotiate horizontal curve, the rear wheel do not follow the same the path of the front wheels. This is known as an off tracking of the vehicles. The required extra widening of the pavement at the horizontal curve depending on the length of the base is nothing but vehicles. For I, radius of the curve is R and psychological factors. And next one is analysis of extra widening of curves. What are the analysis to make a extra widening? First one, mechanical widening. Second one, psychological widening. Why we need to provide? Because in the curved areas, if the moving vehicle does not track in a same track, that is nothing but off tracking vehicles, that's why we need to increase the width of or nothing but a widening of the lane. The total widening should be W is equals to nothing but total widening, W is equals to WM. What do you mean by mechanical widening and psychological widening? W is equals to WPS, psychological widening, plus mechanical widening. So these are the procedure to make a mechanical widening. First one, WM, mechanical widening. R2 is nothing but an second radius, R1 is then first radius. The difference between the R2 minus R1 will be the width of the vehicle that is increased. While considering a triangle OAB, OA square, by applying the Pythagoras theorem, OA square is equals to OB square minus BA square, that is nothing but R1 square is equals to R2 square minus I, nothing but the difference between the R2 and R1, you can call it as an I, that is nothing but OA value. R2 minus WM, nothing but widening by the manual, is equals to R2 minus I2. So I2 is equals to WM into the bracket of 2 R2 minus WM. Finally, the expression is WM is equals to I square divided by 2 into R, nothing but where R is the mean radius of the curve in meters, N is equals to number of the lanes, R is equals to mean. So in the figure we can see here the width is different, here the width is different. Because of the providing the widening in the curve, we are provided a more width. For psychological widening, the expression will be WPS is equals to V divided by 9.5 into square root of R. R is nothing but a radius of curve, V is the design speed of the vehicle in kilometer per hour. Total extra widening. So total extra widening will be WE is equals to, first one we have considered mechanical widening, nothing but WM. The second one will be psychological widening, that is NL square divided by 2R, one expression, nothing but mechanical widening. Second one is psychological widening plus V square divided by 9.5 into R. Just go through this expression. This will be the total widening of the road only in case of the curves. So next one, method of introducing the extra widening. What are the methods? First one, go through with the transverse curve. We have already types of curves in the surveying too. What are the different types of curve? Horizontal curves. In such cases, we have already learned the transition curve. Increase the width of an approximately uniform rate along the transition curve. The extra width should be continued over the full length of the curve, nothing but, see here, this one is the curve, nothing, here is R1 and second one is R2. The increase in the width of R1 to the R2 continued over the full length of the circular curve, because we are considering a circular curve, that is known as a transition. Without transition curve, provide 2/3 widening on a tangent and remaining 1/3 will be the circular curve beyond the tangent point. With transition curve, widening is generally applied equal on both sides of the carriageway. We are not providing a carriageway in a single side. You can see here provided a widening. Both sides we have provided. Method of providing or method of introducing the extra widening. See here. While in case of the long moving vehicles that cannot be turned easily, so to provide a smooth movement of the vehicles for a long turning vehicles, we need to provide a extra widening like this. This will be our S is denoted by the extra widening space for the smooth movement of the vehicles. These are the calculation problems. Calculate the extra widening required for the pavement of the 7 meter width, and the horizontal curve is radius is 250 meter and longest wheel of base is 7. Days and speed is 70 km per hour. Based on the equation you already given, find out the extra widening value, both by psychological as well as mechanical. Second one is horizontal transition curves. What do you mean by horizontal transition curve? When a non-circular curve is introduced between a straight and circular curve as a varying radius with decreasing from infinity at the straight end to the desired radius of the circular curve. So we cannot easily say with the definition, just go through the figure. When a non-circular curve, this is nothing but a non-circular curve is introduced between the straight and circular curve of a varying radius which decreases from infinity, nothing but which may be decreases from infinity to the straight end, nothing but tangent point to the desired radius, nothing but how much radius is required, that is known as a desired radius. This is a circular curve is providing the for the transition curves. This is nothing but the starting point and the one is the end point. Next, objectives for providing a transition curve. What is the main objective? We know already. For the first one is smooth movement of the vehicles and to avoid the skiddy action, to introduce generally to avoid a centrifugal force between the tangent point and the beginning to the circular curve, avoiding the sudden jerk, nothing but for the smooth movement of vehicles. If we provide applying sudden brake, that will be the jerk to the passenger, increasing the uncomfortness. To enable the driver to turn the steering gradually from his own comfort and security, provide the gradual introduction of the super elevation, provide the gradual introduction of extra widening. Next, types of transition curve. These we have already learnt in the surveying: spiral or clothoid, cubic parabola, Laminscale. First one is spiral or clothoid, the second one is cubical parabola, third one is Laminscale. For IRC recommends spiral as the transition curve because fulfill the all requirements, nothing but rate of change of centrifugal acceleration constant and the radius of the transition curve infinity straight to the radius to the passenger, it all comes under the first one, spiral. That's why IRC recommends the IRC spiral is the most economical. Actually there is a small correction in the converting from PPT to PDF. Just go through the expression. LS is equals to nothing but length of shift, which is nothing but shifting the curves, rate of introduction of super elevation, En divided by 2, that is nothing but W plus WE. Totally there are two parameters. The W is the width of the pavement, WE is the extra width of widening provided. So LS is equals to 2.7 V square by R according to IRC standards, and the second one is V square divided by R. Design length of the curve will be the value of highest value in case of the 1 and 2. So here shift or transition of curve S is equals to L square divided by 24 into R. These are the problems. Just go through the problems. Next, setback distance on horizontal curves. Setback distance on horizontal curve. Where there is a sight obstruction, suppose we are turning like this, to turn here one obstacle is there, that will not be visible to the drivers which is presented over the obstacle. In such cases, Site obstruction like buildings, cutback slopes, trees on the inner sides of the curve, either obstruction should be removed or alignment should be changed. If we are possible to move, we can cut the obstacles. Suppose we cannot cut the obstacles, we can remove the alignment should be changed in order to provide a adequate side distance. It is not so possible to provide adequate side distance on the curve on existing roads regularly. Sign should be installed to control the safety and stability. That's why here they will provide a one caution board. There is a circular, there is a curve, there is a deep, or there is a lower in the speed. That will be the signboards can be provided. First one, if the length of the curve is greater than side distance, then m1 is equals to r minus r into d into cos dash alpha dash minus divided by 2 alpha dash divided by 2 is equals to 180 into s divided by 2 pi into the bracket of r minus d. Second case, if the length of the curve is less than the side distance, m dash is equals to r minus into the bracket of r minus d cos alpha dash divided by 2 s minus lc divided by 2 sin alpha dash divided by 2. These are not so much important. Next, this completes your module. Next I will go with the vertical alignment. What do you mean by vertical alignment? Nothing but, see here clearly there is a changes in the gradient, that is known as an vertical alignment. The vertical alignment is the elevation or profile of the center line to the road